In this video, we're going to go ahead and concentrate on relatively simplistic trig functions. I say relatively because there are some secants and that sort of thing floating around in here, but we're primarily going to deal with sines, cosines, and tangents and secants. Because any time you're dealing with a tangent, you probably got a secant kind of looming in the distance. And so just starting off with kind of an easier one. Whenever you're dealing with trig functions, remember that they are a function in and of themselves, and their input can also be a function. And so 2x is actually our inner function in this case. So we can do a u substitution on that. U is equal to 2x, which means that du is equal to 2 dx. So if I want to do a u substitution, I have to have a 2 dx. That means that I can put a 2 out front, but then I have to bring out that 1/2. And so now I have my 2 dx, and that becomes my du, and then I can substitute my u in for the 2x. Now I get 1/2 the integral of the sine of u du. That's equal to 1/2 times, now the integral of sine is negative cosine u plus c. And then if I resubstitute in back into u, this is just 1/2 or negative 1/2 times the cosine of 2x plus c. And then you can take the derivative of this and recognize that, yeah, okay, that's going to work. Okay, so there's a nice simple one. So now that we've warmed ourselves up to trig, let's go ahead and take a look at the next style. Here we have the product of two trig functions. Now in the last, we had sine of 2x, and we just went ahead and used the inner function. Here, we have a distinct issue because trig functions, when you take the derivative, will lead to other trig functions. And you can make either substitution here, it doesn't really matter. But because I know that sine, when I take its derivative, is cosine, and I don't have to add any negatives, I'm going to go ahead and say let u equal the sine of 2x. In that case, then, du will equal cosine of 2x times the derivative of what's inside, which is 2, dx. Remember the chain rule. Okay, so all we need now is a 2 cosine 2x dx. When we do that, I can just throw a 2 out front, or out in front of all that stuff in the integrand, and then bring 1/2 out in front of the integral itself. So now rewriting, I can say it's 1/2 times the integral. I'm going to have a 2 cosine 2 dx. All of that is my du. And then I have, for this, I have u. So now I've got u du on the integrand. That's going to give me 1/2 times u squared over 2, which is equal to 1/4 u squared. U was sine of 2x, and so therefore, when I have it, I'm going to have 1/4 of sine squared 2x plus c. And then if you go ahead and take the derivative of our answer, you'll find out that we get the integrand. It's a good one. I like it. Don't forget, you can also take derivatives of trig functions to help you out. All right, our third and final for this video. It looks a little nastier, but that's all right. We have to recognize here. The trick here is to recognize. Now, the derivative with respect to x of secant x is equal to secant tangent. Now we have secants and tangents, but you'll notice that they're of the same powers. Well, we don't. We have different powers. Okay, so let's choose the other way then. Take the derivative with respect to x of tangent x, and that's secant squared x. Oh, look, we got one. Okay, so what we're going to do then is instead of letting u equal tangent to the 4th, we're going to let u equals the tangent of x. Then du will equal the secant squared of x dx. And now we can go ahead and run our substitution directly. This is going to, we don't have to have any constant of integration changes here. We just go ahead and make our substitution. So wherever we see a tangent x, remember this is really tangent x all raised to the fourth. That's really what it's saying. And so it's u to the fourth, and then this is our du. And so u to the fourth du, which is going to then give us 1/5 u to the fifth, which is 1/5 times tangent to the fifth of x. So see, not too bad. Keep in mind, you can substitute in whole trig functions, or you can just play with what's on the inside.